Today on Chinchilla Squeaks, I am joined by Rob Gibbon of Canonical, one of many Canonical people I've actually had, because you do a lot of different things. But Rob, what specifically are you working on at Canonical?
So I'm the product manager for MLOps and for the data platform here at Canonical. So specifically, we have a solution called Charmed Kubeflow for MLOps, which I'm going to talk about today.
And I'm assuming that's generally as an external service. You may use it yourselves, but it's a service you sell on as a sort of SaaS product to people.
No, in fact, it's a product. So you can install and run it yourself. It's
Okay.
completely open source. And we don't have restrictions on how you consume it. So if you want to run it in production or you want to run it in some lower environment, you can do so. We offer support, 24/7 support, professional services to help people get started with Charmed Kubeflow, and we do offer managed services if people want that, but there's no obligation.
Okay. Let's unpack a few elements of this. Firstly, what is Kubeflow? Because that's not a specific Canonical project, is it?
Right. So Kubeflow is an MLOps platform that was originally conceived by Google, but it's become a kind of contributor-led open source project over time. So it's a MLOps solution that runs on Kubernetes. So it's extremely portable. You can run it pretty much anywhere, and people are doing so. And so that means that you have no constraints about like being tied to Google Cloud. You can run it on AWS, you can run it on premise, you can run it on a couple of servers, and I might demo that a bit later. So that's the history of Kubeflow. It's supported by a bunch of other vendors as well. Yeah. But we have our distribution, Charmed Kubeflow.
We should probably also unpack what MLOps means. I'm assuming machine learning operations, but what does that mean exactly? I have my own kind of assumptions, but what would I be doing with machine learning operations?
Right. So, yeah, it's a very good question. Thank you. In the data science space, I think they say that sort of 70 to 80% of the work is around, preparing data, running experiments, and getting stuff ready to go into operations. And not that much time is really spent on actually building AI models. So Kubeflow and other MLOps platforms help to automate all of the kind of the work around building a model. So for example, if you need to do some complex ETL work, Kubeflow has a workflow engine called Kubeflow Pipelines that helps to automate your ETL. And then beyond that, if you want to run like experiments to find the best possible set of hyperparameters are configurations for machine learning models. So it can be difficult to find optimal hyperparameters if you're doing it by trial and error. With Kubeflow, you have a solution to automate that process. So you can run an experiment in parallel and it will find the best possible configuration for you. So it's things like that. It's also around deployment and operations of your models. Once you've got a model putting it into a prediction or an inference server, as they're called, and potentially even correcting something called model drift, which is where your model starts to underperform all the time.
And so I guess a whole bunch of kind of DevOps-esque type functions as well. Could I also roll back if something went very wrong with a model that went to production? Could you roll it back?
So the idea is that you have things like a model registry where you keep different versions of your model. I can show you. Well, we include MLflow as an extension to our Kubeflow distribution that you can integrate. That then allows you to have like a model registry, a model server, and also to capture metrics around the model. So yes, you do have that. It's also possible to do quite sophisticated things with, for example, GitHub or something like that, where you might have a bunch of workflows that integrate with your Kubeflow environment above and beyond what Kubeflow delivers. So you can go pretty far with it.
I know. I think I've interviewed a couple of explicitly commercial companies doing something slightly different, bringing this kind of this DevOps, GitOps, whatever you want to call it, workflow to machine learning. I think this everything as code mentality is sort of spreading far and wide across many aspects of modern application development, and things like databases and machine learning models were those kind of two ones that were always a bit harder.
Interesting. Yeah, I mean, so I think whilst there's definitely scope for that, and we definitely support that kind of workflow, I think it can be quite intimidating for data scientists. So we're also encouraging, use of tools like Elira, which is like a visual workflow designer tool, so that you can easily connect up a workflow in Kubeflow pipelines in a more intuitive kind of ClickOpsy sort of way. So we support both approaches.
ClickOps, that's a new one on me. So Kubeflow was originally created by Google. It's kind of funny. I'm using a Google Pixel at the moment as a camera, and I'm staring at a Google G, which is kind of confusing as we're talking about them. So what made Canonical want to be involved in it? Like, where did it fit into Canonical's overall kind of business picture?
We have a portfolio approach. We have many products. Of course, the most famous is Ubuntu, but we have a number of infrastructure products like MicroK8s and Charmed Kubernetes, OpenStack, Charmed OpenStack. But beyond that, we are moving slowly towards adopting more and more applications into our portfolio. And Kubeflow is like a very nice application to start with. So,
okay. I mean, there's a lot it packs in here as well. I'd like to understand what charmed means. What is charmed? Yeah. You've mentioned it a couple of times, and I think it's something I've come across a bit with Canonical projects. What does it mean exactly?
Let me explain that. So we have an operations framework called Juju, and Juju is basically it's the framework that we build all of our systems automation on for the applications that we offer. So it gives a unified and consistent experience across the whole of the Canonical product stack. You could see it as a bit like, a platform as a service, except that you can run it yourself in your own environment anywhere you like, or across environments. So you could have an environment running on AWS, somewhere else maybe on Azure or GCP, and an on-premise environment. So perhaps you want to do your testing and your dev work on the cloud, but you actually want to run your real workloads in production. You want to have a consistent experience across all of those environments. Juju is our answer there. So it's a highly hyper-automated, model-driven operations solution for running, platform as a service style workloads. So things like Kubernetes being the obvious one.
Okay. So is it comparable to things like Terraform then, or am I misunderstanding?
It's comparable. It's in the same sort of zone. I say there's a bit of overlap, but it's not the same.
Juju's been around for a while. I feel like when I used to experiment more with Ubuntu, I came across it more. I feel like, I don't know.
Yeah, well, it's been around for quite a long time indeed. So it's becoming deeper and deeper integrated into our applications and our platforms. So I mean, so for Terraform, I think there's overlap, but it's not trying to achieve the same goal. So.
That's fine. Okay, so there's a lot inside Kubeflow. There's a lot of things people will recognize if they've even briefly experimented with machine learning, TensorFlow, MXNet, PyTorch, Spark, Kafka. These are all tools I've messed around with at various times. So there's a lot here. So maybe we should jump into having a look at what things look like. However that may work, I don't know. Sometimes, of course, with developer tools, it's not always as easy to show fully. But let's have a look, and we'll talk some more after that.
So this is the Kubeflow dashboard. So Kubeflow is a browser-based solution. Okay. So you use it over the web or over a web browser. Of course, you don't have to use it on the internet. You can deploy it in your own environment and have privacy. So here you're seeing like the homepage of Kubeflow. You see a few shortcuts and things that I've done recently. There's also an activity tab that shows you some recent activity inside the system. it's showing that some volumes were provisioned. So,
Yep. Okay.
the next thing that you see is the notebooks menu item. So this gives you access to Jupyter Notebook, Jupyter Lab servers that you can spin up. So if I was to click New Notebook, I won't do this now, but you can see that I can choose a name for it, and you see my name come up. Sorry, I can choose the image that I want to run. So it could be one of the pre-selected TensorFlow or PyTorch configurations. You can have it with CUDA for NVIDIA GPUs to accelerate deep learning workloads. We can choose a custom image and specify that here, and it'll pull it down from your image registry. You then have some options around how much CPU you want to assign to this Jupyter Lab server, how much memory, and if you want to assign a GPU, you can do that here, or more than one GPU even.
Could this be a GPU somewhere else?
So it's running on Kubernetes, right? So
it
means that the GPU will be on one of the nodes of the Kubernetes cluster, and it will find it wherever it might be, and it will schedule your workload to run on that node. If there isn't a node available, then you shouldn't be able to get. You see, it's disabled here because I don't have any GPUs on my demo cluster. So the next thing is that you assign some storage with consistent volume in Kubernetes, so that your workload doesn't go away when you stop the Jupyter Lab server. You can add extra volumes if you want. There's various configuration options available. I haven't configured any of this at the moment, but typically you want to enable the ability to use the Kubeflow pipeline CLI from here. Some other stuff as well, and then you would launch your Jupyter Lab. I've already got some running. Well, I've got one running, so I can connect to it here, which will open another tab. Let me share that. And here you see I'm running an environment with Elira. So I mentioned Elira earlier on in this chat. Elira is basically a visual pipeline development environment. I'll quickly show you that. So what you do is if you want to start a new one, you click Kubeflow pipeline editor. Otherwise, there's other things you can do. You can create a Jupyter notebook or start a terminal inside your Jupyter Lab server. This is what a pipeline looks like in Elira. Quite nice. This is a COVID data analysis pipeline on US data. If we just quickly look at one of these notebooks, you'll see that it's...
So it's mapping between notebooks. Okay.
Yeah, so basically each step of the workflow is a Jupyter notebook. You can use other things, but Jupyter notebooks are quite well known to data scientists. Document stuff and...
I kind of love. I'm a huge fan of interactive documentation. I have experimented with them a little, but I haven't had any active use cases to experiment with them more. But I would love to.
You can also, so when a pipeline runs, typically you get an output as an HTML from the pipeline. This one I ran earlier. Sorry, it's the same notebook, but this is the HTML version of it with all the data rendered. If you scroll down, you'll see some pretty maps. Oh wait. Trust HTML first. So you see these nice maps of sort of coronavirus info, hotspots of corona. So when you run the pipeline, it submits it to Kubeflow pipeline. So if I go back to the dashboard, you'll see that there's a bunch of pipelines here, and one of them is that US data pipeline. So I previously ran this. I'll run it in a second, and you can see it. This is the definition of a pipeline as created in Elira and then installed in Kubeflow pipelines. The execution of a pipeline comes here. So you can have many runs of the same pipeline. So if we look at this one, you'll see it ran successfully. You can look at a step, a time series step, and you can get a bunch of information about that, logs. odd. Okay, maybe because it's old. You can schedule them. Okay. So if you want to schedule a run to run every week or once a month or something, you can do that. Of course, you can also trigger them through the API on an event, for example, a GitHub action. But yeah, you can run them one time to a schedule or on a recurring schedule. That's about it. Of course, you have volumes and tensor boards. I'll show you them, but I'm going to show you a run.
Okay. Yep.
Because that's fun. So if we just clone run here and start. So off it goes. It'll take a while to launch on my cluster. So my cluster is a little 3-node system under my desk. So don't expect.
That was actually going to be a question. I mean, obviously the best answer here is it depends, because it depends a lot on the data. But for a reasonably average workload, I guess maybe the better question is kind of what's the overhead on a machine that means could I do this on like a normal desktop machine if I just wanted to mess around with
you can
some 100,000 records or something? Or
you can certainly run Kubeflow on a desktop. I think on a laptop it can push it. So you need about 16 gigs of RAM to get off the ground, but it's better if you've got more. So a desktop workstation, fine. A laptop might be stressed by it. But yeah, so I was going to say that I thought you were going to say how long does it take for a typical workload to run, which is how long to be string. But I think compared to like doing all this kind of workload in a database or a data warehouse, it's pretty fast. I mean, you're offloading a lot of the kind of heavy lifting and heavy computation out of the data warehouse onto a kind of side system. For this kind of report, it's very, very efficient. For data, building neural networks, of course, you're not going to do that.
Forgive my ignorance here. It's probably more just my ignorance on kind of machine learning processes. But how is the data getting in to this pipeline?
So in this case, the data came. This is a demo pipeline, so the data came with the pipeline. So it's from Git. It's from GitHub.
Okay.
Cloned off of GitHub, and somebody uploaded it as a binary to GitHub.
And it will reclone that every time? So you say I'm doing a recurring run, but if the data changes...
No, so that's then stored in a blob storage, which comes as part of Kubeflow. Now, if you want to store data somewhere else, for example, in a S3 bucket or Azure blob store or... Oops, sorry, failed run here. Not quite sure why that failed, but typical gods of live demos, right? Quickly moving on. No, if you want to store the data in an S3 bucket or something like that, that's perfectly possible. You would then connect using whatever tools you like, Python or the Boto3 library or something else to that S3 bucket, pull down the data, and then process it in stages in the workflow. It also has support for Spark, so you can use parallel distributed processing on that data as well. So if the data is in S3 or in HDFS or somewhere else, it can handle it. We typically use Ceph when we're installing this for customers. So Ceph is like, it has an S3 compatibility. It also has the ability for persistent volume claims underneath, so for Kubernetes to get its volumes from Ceph, and you can even run VMs on top. Use it for the file systems of VMs. So it's a powerful solution, and it supports like snapshot backups and all the usual stuff. Okay. So Ceph is our kind of Swiss Army knife for this stuff. Within the Charmed Kubeflow solution, it's using that sounds right. It's using Minio as a kind of
yep. They have been on the show and they keep coming up.
They're everywhere. That's all we're using for now. The last thing, just to quickly note, I don't have this set up to demo today, but I'll show it. So the solution has MLflow integration support as well. So we offer MLflow within our Juju ecosystem. So you basically you at the command line you type Juju deploy ML flow, and off it goes, and it pulls this down and installs it onto your cluster. And it's then accessible for you through what's called a relation with Kubeflow, so that then the two environments are integrated. There's authentication in place, so that you can only access MLflow if you're an authenticated user, and so on. So it means that you can then work with it to create experiments, to hold your models and to track model data. Auto ML. So this is the ability to discover hyperparameters, the optimal configuration for your model. So here you see very quickly, this is looking for the least possible loss on a model, and you see it finds it with this. I think this one is the most efficient configuration. So learning rate of about 0.04, momentum of 0.9 gets you there. So yeah. Go for it.
And you have two different options there, I see.
So you have a recommended one in highlight yellow.
No. There's AutoML and KFP.
Oh, so this is something else. So this is Kubeflow pipeline experiments.
Okay.
So this is like, in order to build a pipeline, you have to associate it with an experiment. This is just a way of tracking those.
First, I suppose the question is, just to clarify, what are you adding on top of Kubeflow to make charmed Kubeflow? How much of what we just looked at is your magic sauce?
So what we add is the deployment, the packaging, the automation around it, just making it incredibly easy to set up and run and get running with it. Plus, obviously, we're providing support on this. If you're taking it from upstream, you're not getting any support apart from best effort from the community. So there's that. So we offer nice packaging that works really nicely with additional integrations like MLflow, like Spark, and then we provide proper support on it if the user wants it.
Okay,
that's the value that we bring.
And say I'm excited and I want to go and experiment. I'm just having a look. So I definitely assume there's Debian / Ubuntu compatibility. I can also see basically, in theory, anything that can run Kubernetes, I guess.
That's right. So if it's a version, if it's a distribution of Kubernetes that's working with our software, then in principle we can support you.
Okay, I can actually see I am running macOS, and I can even see brew install Juju, which is confusing that I'm installing kind of a package manager with a package manager, but it's interesting to see. And with whatever you call it, I keep forgetting the mini Kates or whatever you call it, micro Kates. I have tried that in the past as well, and that worked on a Mac as well. So I could also experiment on there if I wanted to.
In principle, yeah.
Windows?
I don't know if I wanted to. Production.
No. Well, I'm not likely to. Anyway, I'm not likely to run a production thing.
It runs on Windows, indeed. Okay. Yeah. So in principle, you could.
So I mean, I think just for that initial experimentation.
Yeah. There's also WSL. So
yes, of course.
Linux, which gives you a full Ubuntu experience under Windows.
Yeah.
So.
Okay. I think I kind of have some experiments I want to try at some point. I don't have quite the time right now, but soon. Around some texts I want to build some models on.
Cool.
But that'll come later. Okay, so one of my favorite last questions is, I think I saw you've just released a particular version.
So it's 1.4. Yeah.
What's new and what's next?
Well, what's new? I think 1.4 was more a kind of maintenance release from upstream, but for us, the additions was, the big feature was MLflow integration.
Okay.
What's next? 1.5 is coming. We also have, a vision for expanding our ecosystem. I'm not going to give too many details away beyond that. But so we have MLflow. We have a vision for many more of these kind of integrations to come. because we see the demand for them from our users and customers. So, yep, that's going to be one of the focus areas.
Cool. All right, Rob, thank you very much for your time.
Thank you. It's been really a pleasure to be on the call, and have a great day.